Greetings, and welcome to Loiters. Hold on a sec. After this video, they're going to be solved. Pharmacometabolomics. What is it? Pharmacometabolomics is a field of metabolomics that focuses on using metabolite analysis to indicate how some people respond to certain medication. Metabolites that occur in body tissues and fluids may reveal a variety of factors that may indicate how a person and their body work, how their drug works, its toxicity levels, and how it affects target substances. Here's the big question. How do pharmacometabolomics affect AML cells and help biomarkers? How do we take advantage of this interaction to help advance drug development? We stimulate a drug pathway with AML and analyze the biomarkers. Wait, hold on. What is AML?
Acute myeloid leukemia. What is it? Acute myeloid leukemia is a type of cancer of the blood and bone marrow. This type of cancer usually gets worse under a rapid period of growth if left undiscovered and untreated. That's what makes AML so scary. There's something wrong, but you don't know what it is. The pathophysiology of this disease is just beginning to be understood at the cellular and molecular level.
Let's talk about the loiter in question, Seraphinite. Seraphinite works through unique cancer-fighting agents that cut off the tumor's ties to the blood vessels. So, how do we utilize this and analyze it? Let's get to work.
Step 1. Stimulating the environment. A lab is a lab, but the metabolomics community is the metabolomics community. We currently are living in a global pandemic, and I don't have access to a lab. Therefore, I had to stimulate this experiment through my old Windows computer, as Prognosis QI has been a fan of Mac OS. Step 2. Drug pathway. Seraphinite is a drug that belongs to the anthroplastic drug class, which is a drug class relevant to cancer treatment, specifically blood cancers. This drug works by halting cancer tumor growth and stopping the proliferation of potentially malignant cells. It does this by inhibiting protein synthesis, as we investigate in this pathway. Seraphinite is administered orally and is taken as a tablet twice a day without food. I created a drug metabolism pathway using pathways. I visualize the reactions that take place once a patient takes a dose of seraphinite.
Step 3. Sampling. Let's meet somebody else, the biomarker we're going to be analyzing. Coming in at 89.09 grams per mole and predicted water solubility 447.0 grams per liter, alanine. Alanine, LAA, is a non-essential amino acid made in the body from the conversion of the carbohydrate pyruvate or the breakdown of DNA and the dipeptides carnosine and adenosine. It is highly concentrated in muscle and is one of the most critical amino acids released by the muscle, functioning as a major energy source. The tricky thing about this biomarker, and one of the main reasons I chose it, is that it is the biomarker of 11 other conditions.
What do we do now? Biomarkers are quite literally red flags. Very general red flags, but we need specific red flags. We cannot have these general red flags since we do not understand what is wrong with us, and our today's solutions, medicine/drugs, and they're developed and become non-existent. In the case of AML, it spreads fast, and the most effective way is to target the blood cells through drugs, but we need to work on its effectiveness. It's really messy in these libraries of ours, and we have a lot to keep track of, but we need to keep track of it. There are many factors that influence the outcome. Environmental factors, factors coming from our own body. So we need order. We need bioinformatics, specifically pharmacometabolomics, to help identify biomarkers and advance future drug development. We can now officially say that those lawyers were